Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, this is a pre recorded session as I'm away, but if you do have any questions, if you're on Zoom, just reply to the confirmation email you got when you signed up for the class, and I'll get to those when I get back. If you're watching on YouTube, just leave a comment under the video, and I'll get to those. And then, same thing with Facebook, just leave a comment underneath the video, and I'll get to those as I can. So my name is Jason Gabrinas. I'm one of Snap-on's national diagnostic technical trainers. Been in the training department the last 10 years or so, starting my 10th year, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep with Snap-on, had about 30 different Snap-on reps that I worked with, as well as the shops that they serviced in order to help everyone get the most out of their diagnostic needs. And before that, it was 8 years at Subaru. So over time, working in the dealership, ended up becoming just like the default diag guy in the shops. I always ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all the weird head scratcher type cars that would come into my bay. Then before that, bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. Our topic at hand today is testing intermittent electrical faults. These are the ones that happen on the third Thursday of the month when it's 68 degrees outside and slightly rainy or what have you. You know, the ones that are difficult to find. They happen over only every once in a while. So those can be the probably the most challenging issues that we can have as well. So a lot of it comes down to workflow, right? So we have to have some sort of a workflow, some form of a way of diagnosing it the same every time, diagnosing things the same every time. Now, of course, it'll branch off in certain places, but it really starts with the top left there, intake the customer. When the customer comes in, you want to make sure that you capture their complaint as accurately as you can. So if it's an intermittent issue that happens, is the vehicle hot? Is the vehicle cold? Is it wet first startup? Is it after an hour of driving? When is it? Once you've done that, then of course we'll take a road test or verify the complaint in some way. Maybe sometimes it might not be a road test necessarily, but we need to verify the customer's complaint. And when it comes to intermittent problems, that's usually the big challenge, is trying to actually duplicate the problem. You could spend an hour or two trying to duplicate it, driving it under the same circumstances. We just need to be able to approach it the same way every time. Then we'll inspect it, and then of course we need to do a pre-scan on the vehicle, diagnose the problem, repair the problem once we've figured out what it is. Then maybe a reset, relearn, recalibration needs to be done, and then a post scan after the fact in order to verify that everything is working as it should. And then, of course, we'll take a post road test and verify that the problem hasn't. So, when it comes to, as I said, intaking the customer, defining the problem is the important part when it comes to these intermittent problems. So, what kind of problem is it? Is it a drivability problem? Is it a no start? Is it a noise? Is it a drivetrain? Is it an electrical problem? What we're talking about today, of course, is going to fall under that electrical problem. But an intermittent electrical problem could cause a lot of these other things, could cause a drivability problem, could cause an intermittent no start. An intermittent electrical problem could cause an intermittent no start. Noise, maybe. Drivetrain, possibly. More often than not, it's going to be some sort of an electrical problem, drivability problem that we are chasing with this intermittent electrical diagnosis. So a good rule of thumb is to use some sort of a customer interview worksheet. Now, this is one that I pulled from ShopKey that's readily available in there. You can print out. But the section that's most important, especially for intermittent problems, is going to be this section kind of towards the bottom. So, what's the problem frequency? Does it always happen? Does it happen often? Does it happen occasionally? It's an intermittent problem. More than likely, it's going to be occasional. Usually occurs morning, afternoon, anytime. Engine temp, cold, warm, or hot. Vehicle speed, low, cruising, or high. What are the driving conditions during the occurrence? Is it short? Is it stop and go? Is it 2 to 10 miles? Is it more than 10 miles? Headlights on, AC on. All these different things are going to affect where you need to look on the vehicle. What are your driving habits? What is the outside weather doing when this happens? Is it cold? Is it warm? Is it dusty? Is it rainy? What's going on outside the vehicle as well. So once we have that information, we can at least start down a path as to where we might need to be looking, where we need to be going. We also need to determine what type of circuit we're looking at. So since we're looking at an electrical problem, we're dealing with electrical circuits. And if we have a problem in the circuit somewhere, that's where it's going to show up. So the different circuits that we're going to deal with on the majority of the time, we have the simplest one is a series circuit. So point to point, we have power come in from the battery here. We got the battery, we got the ground. The power comes out, lights up the light bulb, or makes the load operate. Might not necessarily be a light bulb, could be a motor, a sensor, something of that nature. Powers the load though, and then we also have a ground on the other side, and they kind of go together through the body or what have you. So if I have a break anywhere in a series circuit, whatever the load is, isn't going to work. So if I have a break on the power side, load doesn't work. I have a break on the ground side, load doesn't work. So those are probably the easiest ones to figure out because it's point to point, and that's what it is. And there's no other outside influence, then it's somewhere within that circuit. Next one is parallel. So I'll have a power that comes out and it'll power multiple loads, and then they all have a common ground that they would also share there as well. So if I got power coming into all of them and then ground coming out, if I have a break in the line, say on the power supply side, before it gets to any of the loads, or I have an intermittent break in the line before it gets to any of the loads, all of the loads on that circuit will be affected. However, if we move the break somewhere further down the line and it's a parallel load, a parallel circuit, we have to think about, okay, well, this load works, but these two loads don't. So where is the problem in the circuit? Also, if we come here, maybe it's a little bit further down past this branch, but now on the power supply side, it's broken there. So this one load doesn't work, but these two other loads that share that same common power work. So you just need to, first off, need to look at the circuit design and see what type of circuit it is. And then we need to determine, okay, what on that circuit works or does not work when we have this problem. Maybe it's all of them, maybe it's some of them, maybe it's only one of them. So with that, you can then determine, okay, where in the circuit do I need to look? Another example circuit is a series parallel. So we have a series circuit up here at the beginning, and then it flows through these other parallel circuits as well. So it flows first through that, and then these that branch off and share. So if we break it before that, doesn't work. We break it after that, before we get to the parallel branch of the circuit, still won't work. But if I come over here, that load will work, that load will work, that load will work, but that load does not. Right, so we have to take that into consideration, the circuit design, how it is set up as to where I am going to test in the circuit as well. So with testing vehicle electronics, which the majority of the time that's what it's going to be, we need to know a few things. What's the operating voltage of the system? Is it AC or is it DC? Because especially nowadays with some of these electric vehicles, we do have AC in the vehicle as well. 5 volts or 12 volts, 48 volts on a mild hybrid, 400 volts on an electric or a full hybrid. What are we working with voltage wise? What type of circuit is it? Is it a series? Is it a parallel? What type of component am I working on? Is it a sensor? Is it a relay? Is it a motor? What am I working on? And do I have access to the information I need to properly diagnose this problem? And do I have access to the proper tooling to test this? So first and foremost, wiring diagrams. Those are very, very important when we're dealing with intermittent electrical problems, because this will give us the lay of the land. It'll tell us where everything is in relation to each other on the circuit. So for example, this was off a Ford Explorer that we did a case study on. And depending on where the break is in this line, these sensors share a common 5-volt reference line. So you see right here, there is a splice in the center of the engine compartment. So if the brake is here, nothing off this splice is going to work. If the brake is here, these two sensors would work, but whatever's on the other end of that branch won't work. If the brake is here, then this one won't work, but these two will. So we need to understand this is a parallel circuit because we have this branch right here where they branch off and it feeds multiple things. Now on the other page, I didn't print out the other page, but on the other page, maybe there's another thing in line. So maybe it's a series parallel circuit. But when I'm looking for, maybe I have an intermittent issue with the throttle position sensor, maybe the problem's in here if I'm not having a problem with the other sensors hooked up. Also, having component testing information is key. So in this case, this is a crank position sensor. So how does this particular crank position sensor work? Because there's multiple different types. It's a variable reluctor sensor in this case, proportional to engine speed. It's a crankshaft mounted trigger wheel. That's 36 minus 1 sensor ring mounted to the crankshaft. The missing tooth is used as a sync signal for coil firing. Provides base timing and crankshaft speed RPMs to the powertrain control module PC. So that is, and that's on that same Ford as well as Ford Explorer. So we can see there's a negative and a positive, and that is an analog signal in that case. What type of component are we working on? What type of component are we trying to diagnose this problem with? So is it a signal generator? Is it a voltage generator, a frequency generator, a magnetic field generator? Is it a solenoid? Is it a switch? Is it a relay? Is it a thermistor? Is it a motor or an actuator? They're going to have different properties with them that you need to also understand and wrap your head around when you're trying to diagnose it. So, for example, say a solenoid, right? So, if the solenoid isn't working, is it on the power supply side and it's just not letting it through? And internally, maybe the solenoid has a problem, or is it on the I'm actually referring to that sort of thing. Is it inside? Is it broken? Or is it power? Or is it ground? What is not working? Because the break in the line, the intermittent problem could be in the solenoid too. If it gets too hot, could be a problem. If it's too cold, it could be a problem inside a solenoid. Same thing with relays. Is it the control side of the relay? Or is it the side of the relay that actually does the switching? So you need to understand those types of things as well. And also, how do we know a circuit can carry a load? Let's think about this. So if we connect an ohm meter, if I'm just using an ohm meter to diagnose electrical problems, which it has its place, but it definitely shouldn't be the only thing that you're using to diagnose electrical problems because it does have limitations as well. So if we connect an ohm meter to 130 strands of copper wire, what do you think the reading would be? Just assume that there's no other issues with this wire, and what would we see for a reading? Well, most likely it's going to be pretty darn close to zero because we have continuity. Everything's through there. Minimal, if any, resistance in the wire, depending on how long it is. So if we connect an ohm meter to that, say it's a battery cable to a starter, should be zero. What if I take one strand of that copper wire out and put an ohm meter on it? What am I going to get for a reading? Well, it's still going to be zero, right? Or pretty darn close to zero, because it still has continuity and all that. But with that, do you think that one strand of wire is going to be able to carry any sort of a load, at least enough to start a vehicle? For sure not. And if I have a frayed wire somewhere, which oftentimes can be an issue with an intermittent problem, can be frayed, it can be intermittently shorting out to something or rubbing on something. That's fairly common, actually. So don't rely on just ohm meters because it could still lie to you. Well, it's not really lying to you. It's telling you what the problem is, or it's telling you what the resistance is in there. What the with the ohm meter, it's gonna tell you what the resistance is, but it's not going to tell you whether it can carry a load. So how about a voltage drop test? That is a very useful test in order to find out where in the circuit the problem may be. So we're going to take our meter, a voltmeter, and we are going to check with the voltage drop. So poor or corroded connections may cause unwanted or excessive resistance. We see we have this little green resistance there. This can affect the accuracy of sensor inputs and outputs. Excessive circuit resistance can also cause circuit components to operate poorly or not at all. So circuit resistance causes voltage drop below normal. Circuit resistance before or after an electrical load can cause electrical problems, much like these intermittent problems. Measuring the voltage drop across the circuit is a method of checking circuit resistance. Connect the tool across the suspected area. So I'm going to take and put my voltmeter, I'm going to put a positive at the battery, and I'll put a negative somewhere along the line to find out where it is. Circuit has to be live, and the component or load must be energized for the voltage drop to be measured. So maximum voltage drop that you would want to see, or anything above this, would be bad. High current positive, 200 to 500 millivolts. High current negative, 100 millivolts. And PCM circuits, 50 millivolts on light gauge wires. Low current, 90 to 100 millivolts. And then solenoid switch contacts, no more than 300 millivolts voltage drop. So in this case, we see from here to here, the voltage is only 0.01. So that's well within spec where it needs to be. But if I move it on the other line, we see that we have 1.03. So that's a 1 volt across the board there. So we can see that that's an issue. And these lights, because they are a load and they're not getting sufficient current flow, they're still getting current flow, but they're not getting sufficient current flow. They are now dim. So oftentimes to check a load on a circuit, some folks will use a headlight. They'll plug in, they take a halogen headlight, like a sealed beam or whatever, and they'll hook up power and ground to it and see, is it bright or is it dim? Easy enough way to do it. If it's dim, then we know we have some sort of resistance in the circuit and it's an issue. Otherwise, if it's nice and bright, then we shouldn't have an issue because that headlight's a decent load on that as well. Um, Oftentimes you'll find people do like a wiggle test. Hook up the light, nice and bright, wiggle it, it flashes on and off, or it gets dim and gets bright. So many useful methods for doing this, but basically when we have that electrical problem, it's going to make the circuit not operate the way it is designed. So we need to just figure out how it is damaged or how it's not working in the intermittent time. We also have to remember that when we're dealing with computer circuits, say, BCM, PCM, what have you, you need to think about it as a computer almost. So we have inputs and we have outputs. So we can monitor the inputs, we can monitor the outputs and decide where the issue is there too. So for example, on a BCM, inputs could be switches, sensors, data. Outputs could be motors, lights, and even more data could have an output there as well. So let's think about like a window motor, right? Window motor, old school window motor. Back in the day, right, we would have power come in and we have a switch and then we have relays, window down, window up in this case. And then when it closes the relay, it moves the window either up or down. And it's a very analog process, right? We push the button, it flips a switch, which flips a relay, which then sends voltage to the motor and tells it which way to go up or down. So depending on where the voltage goes, if it goes on the up or the downside. On a newer vehicle, though, you'll see now on this left rear window switch on this vehicle, there's a logic board in there. So it has network communication that comes in, door to jar switch, in this case, battery grounds, up and down controls. And then that, depending on how this logic board decides, will move that window up or down with that. Sometimes it can be even controlled over a LIN bus. So in this case, there's a LIN bus that comes off of the body control module and it goes over to this left rear window there. So it's the switch sends a signal to the body control module. The body control module then sends a signal over to the window, and then the window motor assembly logic board tells it to go down. Right? So it could be a lot of moving parts. So we need to decide where's the intermittent problem. Is it on the input side or on the output side if we're dealing with something like that? All right, so here's just another example on a Cadillac, right? The motor and the logic board and everything is all laid out, and then the switch is separate. So the switch sends a signal over to the logic board. The logic board then tells the motor what to do. So let's walk through a few scenarios, a few useful tips and tricks that we can do on the tool, or maybe even with our repair information as well, to see how we might approach some of these problems. All right, so let's look at a few things on the tools. So first off, let's go into shop key here and repair information. I have a 2012 BMW 328i pulled up. And as we can see, looking through this circuit, this is just a power supply circuit for, let's see, it shares with the crank sensor, the DISA controller, oil condition sensor, air mass meter, fuel tank vent valve. All of those are on this same one power supply circuit. There's also a connector here in the middle. And then if we look, there's another connector here, and then this goes right to the fuse panel. So there's a fuse there, and then that powers all of these things. So depending on where my problem may be, maybe I have an intermittent output on the crank sensor, for instance. Maybe it works sometimes and sometimes it doesn't. Well, maybe the problem could be in this line. Or if the crank sensor and the oil sensor are giving me trouble, and one of my variable valve motor, the DISA controller there, is giving me trouble, then maybe my problem's over here. So being able to narrow down where your problem actually is a big help. Another thing to look into is, since it's going through multiple connectors, pin fitment, pin tightness is important on some of these things too, to try and find where you might have a problem. Doing a voltage drop test throughout that is also helpful. Like we said, go across here to another page. We'll see there's a splice here, and goes through a connector, and then there's a splice here. There's a multi-splice in this section that covers the Vanos system. So we got the exhaust cam sensor, intake cam sensor, Vanos solenoids on both sides, and then the map thermostat as well. And the electric cooling pump all share power coming from this section. So if I'm looking for a power problem on the vehicle and multiple things have failed, or multiple things are intermittently uh, coming in and out of problems, then that might be where to look. So you always want to make sure you look at the wiring diagram first, because oftentimes they'll share power across the board. Maybe it's a 5-volt reference or a 12-volt in this case. You can see that across the board that they all share. The other side of that coin, though, could be, we can go into, let's see, I have the Silverado here that we can look up. And in there, I was looking through the bulletins, and we will see prevent T gas. Okay. So if we look through the TSBs on this, there are bulletins in here relating to, if we go say body electrical, right? There's a really interesting example right here. No crank with these DTCs. And this is a problem with shorting out on the stator in here. So you can see if there's arcing on there. You could see that could cause a problem. So that could be an intermittent issue with the charging system. Come back over here, and there's another one. Let's see, intermittent malfunction indicator lamp with this DTC. So that's, once again, it's called out as an intermittent problem, 2018 and prior, GM passenger cars and light duty trucks. And if we go down here, any 5-volt reference DTCs are set, refer to the trouble code itself. If they're not set, proceed to step 3. And then it says inside the harness, the condition may be caused by water intrusion into the instrument panel to body harness connector, which carries the APP sensor signal. So it actually it sets a accelerator pedal position sensor code intermittently, also intermittently turning on a check engine light. So that sounds like a very intermittent problem that you would have to find. So checking TSBs will be a big help sometimes, depending on what your intermittent problem is. They may call it out directly as to what that intermittent problem is. And then there was a third one in here too. Let's see. Yeah, for multiple misfire codes, right? So misfire codes and cat codes. So in here, the problem is a ground terminal. So the ground terminal can be on either on the front or the back of the head, depending on what vehicle we're looking at. But there's a ground strap, and that can have problems with it too. Numerous problems also reported on V8 truck engines in GM with where the harness might rub on the back of the intake manifold as well. So that would cause an intermittent problem. If it just rubs up, it causes the intermittent problem. It stops rubbing, it goes away. So multiple ways to look through this. Look through your repair information. The TSBs, wiring diagrams can give you a lot of good information depending on what you're dealing with. You just have to approach it logically and kind of narrow it down as to what the issue actually is. Another way we can get information is if you have one of our tools with a lab scope in there, you can go to guided component tests. And in here, in the classes, not even necessarily in a vehicle test, but in the classes under how to, we can go in, and there are multiple different things we can look at. So we can look at things like, let's see, electronics classes, just general electronics classes to learn a little bit more about it, electronic components. There's another one down here on voltage drop diagnosis, right? So it's going to walk you through different things. So an example of, what you're going to see when you do a voltage drop test, and they'll give an example for a headlight, starter, charging system, and then other hints and tips for testing are in here as well. So there is a lot of information where you can study up a little bit more on this topic than what we've covered today. And then here's just an example test as to where in the circuit, find the voltage drop, and then find the problem. So those are some really good examples right there. Also, we need to make sure we're using the right tool for the job. So as I said earlier, sometimes a meter will work good for it. Other times you need something a little bit more than a multimeter in order to check. So for example, let's go into our scope multimeter on the tool here. And first one I'll pull up is the digital multimeter. So this would be very much like your volt ohm meter. It's the same type of principle. So we'll go into volts DC. And if we look at the signal I'm measuring, it says 5.01 volts. Now that's great. But I will tell you right now, I'm looking at this, reading the voltage, and it's really not changing much. 5.01, 5.02. I have an intermittent dropout happening right now with my sensor simulator here, the signal generator. I know there's a dropout in there because I put a dropout in it. So if I was trying to catch an intermittent glitch just using a voltmeter, not going to work. Now, if I do have, say I needed to, maybe I had a larger glitch where it kind of did that. I just unclipped it real quick for a second. So it drops down to like a couple tenths of a volt. It doesn't drop down that much just for really a longer length of time opening it, because I can't open and close this as fast as the glitch is going to happen. But as you can see, it does drop down. It'll catch it a little bit. You'll see a couple tenths of a volt drop, maybe something like that. Now, if I wanted to really see what's going on, we have two other options. We can go in under graphing multimeter and do it this way, volts DC, and then we can see that, yes, there's a dropout every so often in here. And it's like I said, it's on a voltage signal generator. So it is happening at a regular pace, but we can see there is a dropout. And that's just by graphing it. And the graphing will react faster than the multimeter. We want to go even faster, though, and catch even shorter things we may need to. We can go into the scope and do it that way. So in this example, we can see every once in a while we'll see a glitch, but we're not necessarily catching it. And the reason behind that is with the scope, you also need to use, if you're trying to catch something like this, you need to use the trigger as well. And you'll notice if you look at the screen, there's no trigger on. So I'm going to come down here and turn the trigger on. And when I do that, you'll see that it catches it every time it happens. And it puts it in the same place. If I move it over here, it's going to catch it again. If I move it over here, it's going to catch it again. Now, there are two different types of trigger that we use on the scope as well. So in this case, we are looking at, let's see, which trigger is this? So it's a manual trigger. If I go into auto trigger, it is going to collect it and it's just going to show it on the screen whenever it happens, and it'll catch it in that spot. So it'll continue recording, and then it will drop down, and then you see when it stops, it goes away, and then it drops down, and it says waiting for trigger. So that's all well and good if I need to put a pattern on a screen that's a repetitive pattern. If I'm just trying to capture a glitch, what I really need to do is flip it back to that manual trigger, and that way it'll record until it has a problem, right? And then when it does have a problem, the problem will show up. So let me turn the glitch off and show you what that would look like. All right, so I turn the glitch off. I have to restart recording, so I'll stop and record. And now you'll see with my manual trigger, nothing's happening because it is not contacting this trigger. Remember how it would come in at about 5 volts and then would drop down. Anytime it passes that trigger is when it starts to draw it on the screen. So now I will introduce a glitch into it, and then we'll see what happens. So I could just be recording. You might not think anything's even happening because you can't see the voltage on the screen. But if I just really quick unclip it, we can see that it catches it on the drop, and then it freezes it on the screen. So I could just let this roll. I could let this roll for if it's a problem that happens maybe once an hour or something like that. I could just let it roll. And then when it glitches, it'll catch it with that trigger point on the scope. So in this case, I'm looking at a 5-volt signal, and I'm trying to catch it glitch into ground. So in that case, I have it around like 2.5 volts or so is where that is. If I brought it down further below 0, because it's probably not going to go negative, right? So if I open it up, it's not catching it. So the trigger point has to be in the right spot. That's one thing it needs. It needs to be in the right spot for one. The other thing is it is on what we call a a negative slope or a falling slope right now. So you see how it's squiggly, top left to bottom right. So that's going to catch the signal when it goes down. So I have this on a downward slope, and it's right here. It's not catching anything. But if I open it up, it's still not going to catch anything because it doesn't go above 5 volts. Now, if it was shorted, if I was trying to catch a short to power, that would be where I'd want to put it above that 5 volt line. So it's shorting to maybe 12 volts. So it's only going to catch it on the way up or the way down. So I'll pull it back down here around like 2.5 volts again. Now let's change the slope the other way. So I'm going to change it on the way up. So I'm going to unclip this, and then we'll see what happens when I do this. There. So I unclipped it. It didn't catch anything when I unclipped it. When I reclipped it and it went back up, when it reconnected itself, then we catch it on the way up. All right. So we have two different ways that'll work. It either work on the way up or on the way down. And when I reset it, it resets itself. So that is, like I said, really helpful to catch one of those little quick dropout glitches that you don't know when it's going to happen. You could just leave it monitoring the signal, whatever it happens to be. If I'm looking for a quick dropout, or if I'm looking for a quick voltage spike or something like that, I can just let it roll. And then when it does, it will catch it and it'll freeze it on the screen and lock it in place. That's using the manual trigger on that. All right. So hopefully we got some tips on this. That's my time for this part anyways. Let's talk about what we're going to see next week. So next week, we are going to get into our last of this batch of 5 new classes, and it'll be 48-volt mild hybrid operation and testing. So I touched on it a little bit in starting in charging systems and batteries later last year, towards the end of the year last year, but let's get right into 48-volt mild hybrids. There's a lot more of them out there than I was aware of when I started researching that back then. So we're just going to expand upon that a little bit, talk more about how they operate, how they work, what things we can do with our scan tool and scope to be able to test those things. So join me same time, same place, 6 and 9 Eastern on every Tuesday. Go to snapon.com/OT if you want to join me on Zoom. Also, the 6 p.m. Eastern class goes live to YouTube. So make sure you check us out over there, youtube.com/Snap-on Diagnostics. If you're watching this on YouTube, please make sure you like and subscribe and ring that little notification bell. It helps everybody with the algorithm there. And then the 9 p.m. Eastern class goes live to my Facebook page. So it's facebook.com/Snap-on Jason, all one word, no dash in the Snap-on. And go check it out there. If you want to see any of our past topics in this series, anything from ADAS through guided component testing, coding, immobilizers, hybrid operation, all of these things, 60 plus, because this would be episode 61, 60 plus topics that you can go and check out any time of day, anytime you need to, for free, available on our YouTube channel, youtube.com/Snap-on Diagnostics. And then there is a playlist for live training that you can go and check out over there. So make sure go check it out. If it's free, if it's free, it's for me. So I always like being able to access all this free training. Okay, now it's time for questions. So this is a pre-recorded session. So if you do have questions, if you're on Zoom, just reply to the email that you got in confirmation. If you're watching on YouTube, just leave a comment underneath and I'll get to those. And then if you're watching on Facebook, leave a comment and I'll check those out when I get back. Also, I'd like to mention my buddy Keith. Keith also does free diagnostic platform training every Wednesday and Thursday. On Wednesday, it is on Zeus. So, and then Thursday, it is on Apollo and Triton. So on the beginning first hour, it is going to be on let's set up your tool, let's set up your Wi-Fi, let's set up your free Snap-on Cloud account. And then he'll walk you through on the scanner side, code to completion on Fast Track Intelligent Diagnostics. After a 5-minute break, he'll come back and talk about guided component tests and scope and meter and all of the functions on that side of the tool for the second hour. So they're about 2 hours long with, like I said, a 5-minute break in the middle. So Wednesday, as I said, is on Zeus. Thursday is on Apollo and Triton, kind of a combo class. And if you want to sign up, snapon.com/OT. That is Zoom only. So just go sign up there to save your seat in class. 7:30 Eastern both nights. He does one session a night. Go check that out. And with that, I'd like to thank you for taking a little bit of time out of your day to spend a little bit of time with me. Hopefully, we learned a few more tips and tricks that we can apply in the shop, hopefully, maybe even tomorrow. So with that, enjoy the rest of your week. Enjoy your weekend. Have a great night and take care.